Hello students, myself Dr. Vijayalakshmi. Welcome back to the class Aldehydes and Ketones. In the last class, we studied about preparations of aldehydes and ketones. In this video, we are going to study about reactivity of aldehydes and ketones in some special reactions. The carbonyl group of aldehydes and ketones, the carbonyl group, among that already we have seen the structure, carbon and oxygen. Oxygen is being more electronegative and shared pi electrons are somewhat shifted towards the oxygen. And we can write the resonance structure here. Because of the more electronegativity, the shared pi electrons of the CO bond are shifted on the oxygen, so that oxygen gets a negative charge and carbon gets a positive charge. So collectively we can write here oxygen having small negative charge and carbon having small positive charge. So when a nucleophile approaches this carbonyl group, so initially the carbonyl group, it is a trigonal shape due to sp2 hybridization. The shape of the carbonyl group is trigonal. When a nucleophile approaches, that nucleophile attacks on the electron deficient carbon, and carbon nucleophile new bond is formed and oxygen gets a negative charge. Now the carbon becomes sp3 hybrid carbon. Okay, the carbon becomes sp3 hybrid carbon, and as a negative charge on the oxygen is present, it accepts a proton and forms OH bond. So after the addition of a nucleophile, this sp3 carbon is converted in sp2 carbon is converted into sp3 carbon, and the shape of this carbonyl group, initially it is a trigonal and now it becomes tetrahedral because the carbon is now sp3 hybrid carbon. And this is how the nucleophile will react to the carbonyl group. Now we will see some reactions of aldehydes and ketones, some specific reactions, that is nucleophilic addition reactions. In the nucleophilic addition reaction, we will take first example HCN, hydrogen cyanide. In the hydrogen cyanide, the H is plus and Cn is minus. When hydrogen cyanide is added to the carbonyl group, H goes to oxygen, Cn goes to carbon, so that CCN new bond is formed, OH. So these are called cyanohydrins. A cyanide group is also present and OH group, so cyanohydrins are present. When aldehydes or ketones treated with hydrogen cyanide, cyanohydrins are obtained. For example, acetaldehyde, when treated with hydrogen cyanide, it gives acetaldehyde cyanohydrin. Or if a ketone, for example acetone, when treated with hydrogen cyanide, acetone cyanohydrins are obtained. This reaction is specifically used to increase the number of carbons in the chain. So here carbon is introduced, a new carbon in the form of cyanide group is introduced. So suppose new carbon means if we want aldehyde, then C or COH, then CN bond is hydrolyzed to get corresponding aldehydes or carboxylic acids, or on complete hydrolysis and reduction gives methyl group. So to introduce a new carbon in the chain, this reaction is specifically used. Let us see the mechanism how this hydrogen cyanide is added. So this is base catalyzed reaction. In presence of a base, the OH minus of the base will accepts a proton from this hydrogen cyanide. As Cn is more electronegative, the electrons of CH bond are shifted to carbon, and base will takes this proton and becomes H2O. So nucleophile is generated. So first step is generation of a nucleophile. So this is base catalyzed reaction. In presence of a base, a nucleophile is generated. This nucleophile attacks the carbonyl carbon. Among this carbonyl carbon, one of the bond, that is CO pi bond electrons, are shifted towards oxygen in presence of attacking reagent, and carbon becomes plus carbocation. So to this carbocation, this nucleophile attacks, so that new CN bond is formed. This reaction takes place slowly because in the in the compound, the polarity is introduced here through this nucleophile. After once the anion is formed here, the reaction becomes fast. This will again takes a proton from the water, and which is formed in the first step. It takes proton from the water and becomes OH. So cyanohydrins are formed. Whether the cyanohydrin is obtained from aldehyde or ketone, depending upon the prefix name of that compound is added. Aldehyde cyanohydrin or ketone cyanohydrin. So this is how the hydrogen cyanide is added to the aldehydes or ketones, that is the carbonyl compounds. Acetal formation. When carbonyl group reacts with alcohols, acetal's formation takes place. Acetal formation takes place in two steps. In the first step, hemiacetal formation takes place, and in the second step, acetal is formed. So in the carbonyl carbon, when treated with alcohols, it reacts with two molecules of alcohols and gives acetal. The reaction takes place in presence of dry HCl. So this is base catalyzed reaction. So in the first step, so again among this H plus and RO minus, alkoxide ion plus proton is obtained. The H plus goes to electron rich oxygen and alkoxide ion goes to carbon, so that it gives hemiacetal, OR and OH. The hydrogen of this alcohol goes to oxygen, and this alkoxide ion RO minus, this goes to carbon, and it gives new CO bond is formed, COR and OH. This is called hemiacetal, but these hemiacetals are unstable and it undergo addition of another one molecule of alcohol. So that may be a same alcohol or a different alcohol. So that's why here R dash is taken to show different alcohol, or the same alcohol can be taken. Again in presence of dry HCl, this another molecule of alcohol is added and it gives acetals. These acetals are now stable compounds. So for example, aldehydes, acetaldehyde when treated with ethyl alcohol in presence of dry HCl, it gives first the acetal, hemiacetal. After that it reacts with another one molecule of ethyl alcohol, acetaldehyde diethyl acetal is obtained. So acetaldehyde, diethyl acetals are obtained. This takes place in two steps. In the first step, hemiacetal formation. In the second step, acetal formation. In presence of an acid, so this reaction takes place in presence of dry HCl. So in presence of an acid, CO bond electrons, the pi electrons of CO bonds shifted towards oxygen and carbon becomes plus. So this accepts a proton from the acid. So it becomes OH and C plus. So the protonation of aldehydes takes place in the protonation of aldehyde takes place and it gives carbocation. This carbocation next reacts with alcohol, one molecule of alcohol, and from this oxygen of the alcohol is having a lone pair of electrons, so it is rich in electron, and through this oxygen it will react with the carbocation so that new carbon oxygen bond is formed. For the formation of new carbon oxygen bond, oxygen loses a pair of electrons, so it gets a positive charge. Now one of the OH bond electrons are shifted to oxygen, so H plus is removed and it gives hemiacetal. In the second step, this hemiacetal again in presence of acid. So in the hemiacetal, again the OH group, one is the alcohol group and another one is a ester group, and from this alcohol oxygen reacts with the H plus of an acid and get protonated. So after the addition of protonation of this hemiacetal, up to this the reaction is fast, and after that slowly CO bond electrons are given to oxygen so that H2O, this H2O is removed and it forms this carbon gets a positive charge because of losing the electrons. Now the electrons of lone pair electrons of oxygen are shifted to CO bond, so that here carbon oxygen double bond is formed and the oxygen gets a positive charge. Now this is ready to react with another one molecule of alcohol. With the lone pair electrons of oxygen, the alcohol reacts with carbon and one of this CO bond, that is pi electrons, are given to oxygen. So again OR dash, this ester group is formed back and alcohol group is added here. Now OH bond electrons are given to oxygen so that H plus is removed. So acetal is formed. So there are two steps. In the first step, hemiacetal, here addition of one molecule of alcohol takes place, but these hemiacetals are unstable. They further undergo addition of another one molecule of alcohol and to forms acetals. Reaction with ammonia derivative. This is also one of the important reaction. Some ammonia derivative. Ammonia is NH3. So one of the hydrogen from this ammonia is replaced by R. R means any alkyl group. So here indication Z is taken. So any alkyl group, or maybe it is aryl group or another one amine group or alcohol. So depending upon that, different ammonia derivatives are there. When aldehydes and ketones, when reacts with this ammonia derivatives, they form like the condensation products are formed and C double bond N bond is formed with the elimination of water. So see here C double bond N when ammonia, from the ammonia derivative, when aldehydes and ketones are treated, a mole of water is removed and C double bond N new bond is formed here. So mechanism of this reaction is, so ammonia derivatives act as a nucleophile because the nitrogen of this amine having a lone pair of electron, so itself it acts as a nucleophile and adds to carbonyl carbon of the aldehydes or ketones. So through this lone pair of electron, the amine group react with the carbon so that carbon nitrogen new bond is formed. For this new bond formation, nitrogen loses a pair of electron, so it gets a positive charge. Now, from this amine group, one of the NH bond electrons are given back to the nitrogen and H plus is removed. So, that proton is transferred to O minus. So, proton transfer takes place. So, from the amine group, the proton is transferred to O minus. So, this intermediate is formed C single bond N, nitrogen gets its lone pair of electron, but still it is unstable. So, in the next step, addition of product rapidly, the addition product which is formed in the first step, that rapidly loses a molecule of water to give the final product. So again one of the NH bond electrons are given to carbon nitrogen. So H plus is removed and this CO bond electrons are given to oxygen so that OH minus is removed. So totally H2O is removed and C double bond N is formed. So this is a stable product now. Which are the ammonia derivatives then? So we will see hydroxylamine. This is one of the ammonia derivative. One of the hydrogen of ammonia is replaced by the OH group, hydroxylamine. When hydroxylamine is treated with aldehydes or ketones, oximes are obtained. C double bond N OH. Oximes are obtained. For example, acetaldehyde, when treated with hydroxylamine, acetaldehyde oxime is obtained. When acetone treated with hydroxylamine, acetone oximes are obtained. So this reaction is used in the identification or detection of the functional group present in the molecule. Whether the carbonyl group is present, then corresponding oximes are obtained. So to test that presence of aldehyde or ketonic group, that is totally the presence of carbonyl group in the compounds, the compounds are treated with hydroxylamine, and if oximes are obtained, then it is confirmed that carbonyl group is present. Another one example is hydrazine. The hydrogen of ammonia is replaced by amine group, another one amine group. So it is called hydrazine. Again, in between these two, a mole of water is removed. That mechanism already we seen, and it forms the hydrazones. So hydrazone is a yellow color product. So hydrazine and carbonyl compounds are added and heated. The yellow color precipitate obtained shows that hydrazones are formed. It is also used in the detection of functional group, whether the carbonyl group is present in the compounds. To test that, this reaction is used. For example, acetaldehyde, when treated with hydroxylamine, it gives acetaldehyde hydrazone. And when acetone is treated with hydroxylamine, it gives acetone hydrazones. Another derivative of ammonia is phenylhydrazine. So see, one of the hydrogen of ammonia is replaced by NHC6H5. So this is phenylhydrazine. So these aldehydes or ketones, when treated with phenylhydrazine, phenylhydrazones are formed. So these phenylhydrazones are also yellow color products. So formation of yellow color indicates phenylhydrazone compounds, and that confirms the presence of carbonyl group in aldehydes and ketones. So corresponding examples: acetaldehyde, then acetaldehyde phenylhydrazone is obtained, acetone, then acetone phenylhydrazones are obtained. Here, if the ketone having smaller groups, that is CH3 and CH3, then the reaction is fast. If here bulkier groups, the alkyl groups are bulkier groups, then the reaction is slow, because that groups, the bulkier groups, due to the presence of bulkier groups, some steric hindrance is created. And another one is these alkyl groups are electron releasing groups. So that's why the reaction is somewhat difficult here. Reaction with 2,4-dinitrophenylhydrazine. So it is again another one derivative of ammonia. In place of H, this 2,4-dinitrophenyl is added. 2,4-dinitrophenyl in place of ammonia. So in the hydrazine, phenyl group, 2,4-dinitrophenyl group is added. So it is called 2,4-DNP. When 2,4-DNP is treated with aldehydes or ketones, it gives 2,4-dinitrophenylhydrazones. So again with the aldehyde, it gives corresponding aldehyde DNP hydrazone, or with the ketone, then acetone 2,4-dinitrophenylhydrazone. Another one derivative of ammonia is semicarbazide. So in place of hydrogen, carbazide group is added. When treated with aldehydes or ketones, again removal of a mole of water, and it gives semicarbazones. Again acetaldehyde semicarbazones are obtained, acetone, then acetone semicarbazones are obtained. So this is another one specific test, Iodoform test. This test is used to confirm whether the given compound is aldehyde or the given compound is ketone. To test that, this Iodoform test is used. In that, aldehyde is treated with iodine. So it reacts with 3 molecules of iodine, and initially iodol is formed. From the acetaldehyde, 3 hydrogens of methyl group are replaced by iodide. So it is iodal. This iodal, after adding alkali, so for the iodoform test, the aldehydes or ketones treated with iodine and base, NaOH or KOH. So after adding a base, iodol is converted into iodoform, and another one corresponding salt of acid is obtained. So this is a confirmative test for aldehydes and ketones. So if acetone is there, there also the same reaction. Acetone on treating with iodine, triiodoacetone is obtained. That on treating with alkali gives iodoform. Another one addition reaction is there, nucleophilic addition. Addition of sodium bisulfite, NaHSO3 thrice, SO3. So when a carbonyl group is treated with bisulfite, sodium bisulfite addition products are obtained. The mechanism of this reaction is, in the first step, ionization of sodium bisulfite takes place. It ionized as Na plus, H plus and SO3 minus. Sulfite ion is formed. This sulfite ion along with Na plus, it reacts with the carbonyl group. So in presence of attacking reagent, the pi electrons are shifted on the oxygen. Oxygen gets a negative charge, carbon gets positive charge. To that, this this sulfite is added. And sulfite group is acidic in nature, so that it reacts with Na plus, that is with the lone pair of electron, it reacts with Na plus. So here salt is formed. Sodium sulfite is added. So as there is a negative charge on oxygen, it accepts a proton which is already present in the media and it forms OH. So bisulfite addition compounds are obtained. So these are some nucleophilic addition reactions of aldehydes and ketones. In the next class, we will see some named reactions. Thank you.